Hello, today I want to take you through verifying trig identities, just a bunch of examples that we can get through. Let's take a look at the first one right here. Let's do tangent times cotangent equals 1. Now on all of these, I want you to follow the same rule. There are going to be some that you have no clue of where to start with, and you just need to start with something. Do not forget your identities, whether they be your Pythagorean identities, or your reciprocal identities, or your quotient identities. A lot of times we can use one or several of them to make our job a whole lot easier here. There's always more than one way to do these. Well, not always more than one way, but almost always, I guess you could say. And so for this first one, when I'm looking at it, I think, okay, I don't know where to start. I'm just going to start putting down something. I know tangent is equal to sine over cosine, so maybe that can help me. I also know that it is equal to 1 over cotangent. And I'm multiplying these two things. So if I let it be 1 over cotangent, and I'm timesing it by the cotangent of x, well, cotangent written as a fraction is cotangent over 1. When I multiply these, the cotangents cancel, leaving me with 1 over 1 or 1. And that equals my right-hand side of the equation. Boom, I'm done. Now, if you're in my class, I want you to take note of a few things. One, pick a side of the equation and stick to it. Don't divide both sides by cotangent. We're not doing any algebra properties with the equal sign. So in this next one, pick the left side and make it look like the right side, or pick the right side and make it look like the left side. Also, do not skip over any steps. Everything should be written there. I'm going to take it that you know nothing unless you show me. Okay? So show me how you get from here to here. Don't just assume that I'm going to think that you know it. You got to show me. All right, so looking at this one, number 2, you can pause the video and give that one a try. All right, I take it that you gave it your best shot. Let's see if you got it right. Remember, just because I do it a different way doesn't mean that your way is wrong, but algebraically, everything should work out to be right. So if you have a question, you're in my class and you're like, hey, I did it this way. Is this acceptable? Come ask me. I'll be happy to help you out. So I'm going to take the left side and work it out to make it look like the right side. And I'm going to break this up into two fractions. The sine of x over 1 times 1 over cotangent squared. And I'm going to see if I can make it look like this over here. Well, I know that sine of x is the same thing as 1 over cosecant. So I can rewrite that as 1 over cosecant of x. And cotangent squared is the same thing as tangent squared, or not cotangent squared, but 1 over cotangent squared. So multiplying these two fractions gives me the tangent squared of x over the cosecant of x. Hey, guess what? That is the original right-hand side of the equation, and so I'm done. All right, let's look at a third one here. And this one's a little bit more lengthy to it. Boom, there it is. I got to get around my picture there. There it is. Pause the video and give that one a try. All right, I take it that you've given it your best attempt. Let's take a look and see how you did. So starting out, I'm thinking, okay, I'm going to work with this left side because there's so much to work with here and try to make it look like the right side. Cosecant is the same thing as 1 over sine. Remember, S pairs with C, so this is going to be 1 over the sine of x times cosine squared. Now, this cosine squared, I'm going to see what I can do with it using my Pythagorean identities. Whenever you see something squared with these trig functions and you don't know where to go, see if you can take out these Pythagorean identities and make something of it. So what is cosine squared equal to? Well, looking at these, there's the cosine squared. And can I make it just by itself here? And I can do that by subtracting sine squared from both sides. So if I subtract sine squared from this side, it goes away. But I also have to subtract it from this side, leaving me with cosine squared equals 1 minus sine squared. If you don't know how to come up with these Pythagorean identities, I do have a video on that. I suggest you go and watch it. So we've got this is the same thing as 1 minus sine squared. And that is being multiplied by this fraction right here. And then I'm going to add to that the sine of x, and I'm trying to make it all look like cosecant in the end. So distributing this 1 over sine of x is what I'm going to do next. I'm going to multiply it times this, and I'm going to multiply it times the second term there. So 1 over sine of x times 1 gives me 1 over sine x. And then I got to say 1 over sine x times a negative sine squared. So just put the negative there. And so sine squared of x is the same thing as sine squared over 1. And when I multiply this fraction times that fraction, the sine squared is in the numerator and the sine of x goes in the denominator. So I get sine squared of x over sine. And then don't forget the plus sine x there. So it looks messy, but it's going to clean up real quickly and real nicely here shortly. Sine squared over sine is just like saying x squared over x, right? So here, let's do that on the side. X squared over x is the same thing as x times x over x. It's just going back to something you know. Well, the x's cancel, and you get, oh, that equals x. Same thing happens with sine squared over x. If I have sine squared of x over the sine of x, this is the same thing as sine times sine, or sine of x times the sine of x, and it's being divided by the sine of x. So just like right here in algebra where we had x times x over x, we can cancel out one of those signs, and I'm left with just the sine of x. So this leaves me with, let's draw a line with our scratch work out of the way, 1 over sine, and this just becomes minus sine of x, and then bring down your plus sine of x. Well, negative sine plus sine, that just adds up to 0, so they cancel each other out. I'm left with 1 over the sine of x, which is equal to cosecant of x, which, hey, guess what? That was my right side of the equation, so this equals the right-hand side. And we're done there. All right, let's look at number 4 here. There it is. Pause the video and give number 4 a try. All right, I take it you gave it your best shot. Let's take a look and see if you got it right. When I see this, I say, okay, this looks a lot like a Pythagorean identity. So maybe I need to go back and look at those. So if you're on a test or quiz, you should have these sketched out somewhere, not brought in with you, but when you start to take your test or quiz, write them out real fast. Remember to watch that video of mine on this if you haven't seen it already. But 1 plus cotangent squared, hey, guess what? I already know what 1 plus cotangent squared here is. It's cosecant squared. So I'm going to say this whole thing right here is the same thing as cosecant squared of x. And I'm multiplying it by sine squared of x. And I want it to look like 1. I want to make it equal to 1. Cosecant squared is the same thing as 1 over sine squared. 1 over sine squared times sine squared. Well, let's make this sine squared a fraction, put it over 1, and notice before I multiply, these will cancel out, leaving me with 1 over 1, which is equal to 1. Hey, that's the right-hand side there. Sometimes these look pretty complicated, and then you do something like use a Pythagorean identity, and it makes it go by a lot faster. Let's take a look at number 5. There it is. Give the video a pause and give the problem a try. All right, remember as we get into more and more complicated problems, you may have chosen a different route than I did. Doesn't mean you're wrong or I'm wrong. We can both be right. Just come check with me if you have any questions of whether or not you did it correctly. So this is cosecant minus sine. So what I'm thinking is, well, cosecant is the same thing as 1 over sine. Remember, if you don't know where to start, just start doing something. So that way you can kind of get the wheels turning in your head on what to do. And I'm going to subtract from this the sine of theta. Remember, we're going to make it a fraction. I want to make this look like the right-hand side of the page there. Now, I can't just subtract two fractions. Remember, it's not being multiplied. We are subtracting in here. But when you subtract and add fractions, you can't just go straight across. You have to get common denominators. And so that's what I'm going to do. The common denominator between the two is going to be the sine of theta. So I need to multiply this by sine over sine. Notice sine over sine, what I'm writing right here in green is the same thing as 1. I'm multiplying 1 times this second fraction here, so they both have a sine in the denominator. That leaves me with 1 over sine. It doesn't need to change. Minus, well, sine times sine is sine squared. And sine times 1 is sine. Notice this fraction right here, if I reduced it or simplified it, it becomes sine of theta. So I haven't changed the value, just changed the way it looked. Now I can subtract the numerators. And this gives me 1 minus sine squared of theta over the sine of theta. And if we look at our Pythagorean identities, if I were to subtract sine of theta from sine squared of theta from both sides, I get cosine squared equals 1 minus sine squared. 1 minus sine squared, that's right here. That, what I just circled, is the same thing as the cosine squared of theta. It has to be a square there. Remember, we were talking about Pythagoras here. So you've got to have that square there. It's not 1 minus sine equals cosine. It's 1 minus sine squared equals cosine squared. So I get cosine squared over sine of theta. And before you're just like, where is he going with this? Remember, that's a good question. Where am I going with this? Always go back and review if you need it. I want to make it look like cotangent times cosine. So when I look at this, I say, okay, what if I were to break this up into two fractions? I'm going to say this is the same thing as saying cosine of theta over the sine times cosine over 1. Double check that, make sure that's true. Cosine times cosine is cosine squared, and sine times 1 is sine. How did I know how to do that? From experience. And as you practice, you will get better and better and better at recognizing what you can do with these. Cosine over sine is the same thing as the cotangent of theta, and then cosine over 1 is the same thing as cosine. And guess what? That is the same thing as the right-hand side there. Maybe you chose to do this one a different way. Like I've said a bunch of times before, it's okay if you go a different route. Maybe you start on the right-hand side, made it look like the left-hand side. It makes it a pain for me to grade because there's so many different options for a correct answer, but that's okay. If you're doing it and doing it correctly, I am very happy that you are on the right path. All right, let's look at this one. Number 6. We've got cosine equals secant minus sine times tangent. Pause the video and give that a try. All right, I take it that you gave it your best shot. Let's see what you did here. I'm going to start with the right-hand side and make it look like the left-hand side. So when I'm looking at this, I need to make this look like cosine. I'm just going to start off by saying, hey, this is the same thing as 1 over cosine. And let's see, minus sine. Well, tangent's the same thing as sine over cosine. So I'm starting to see I've got some fractions with cosine in the denominator. Let's go ahead and make that sine a fraction. So these two things are being multiplied. So I can just say the numerator times the numerator gives me sine squared. And the denominator times the denominator equals cosine. Subtraction sign in between. And notice they have the same denominator. So I can just subtract the numerator and I get 1 minus sine squared over the cosine of theta. And I'm trying to show that this equals the left-hand side. Just the cosine is what it should simplify down to. And so 1 minus sine squared, let's go back. Remember, there are Pythagorean identities. If I subtract sine squared from both sides, I get 1 minus sine squared equals cosine squared. So this numerator right here is the same thing as cosine squared. It's over cosine. And cosine squared divided by cosine, it's like saying it's the same thing when we had x squared over x. One of those x's cancel out. One of these cosines is going to cancel out, leaving me with just the cosine of theta. Hey, guess what? That is the left-hand side of the equation that we started out with there. Okay? So we're done with that one. Let's take a look at number 7. Pause the video and give number 7 a try. All right, for number 7, I'm going to say, you know what? I can split this up. This is a fraction over here on the left. I can say this is the same thing as saying secant of x over the secant of x plus 1 over secant of x. Take a look at that. See how I split that fraction up? Notice if you were to add them, they have the same denominator. So we can just add the numerators and put it over that same denominator. So I'm just kind of going the reverse way that we normally go and splitting it up. Well, secant over secant is the same thing as 1, and 1 over secant is the same thing as cosine, and 1 plus cosine is the same thing as cosine plus 1, so this equals our right-hand side of the equation. Try number 8. All right, when I see number 8, this is what I'm thinking of. I say, okay, I've got the sine of x divided by tangent. Well, tangent is the same thing as sine over cosine. And if it makes you happy, we can make this sine a fraction. So I've got a fraction divided by a fraction. So I can keep it, switch it, flip it. So keep the first one, sine of x, switch to multiplication, and flip the second one. I get cosine over sine. Then when I multiply them, the signs will cancel, leaving me with the cosine of x, which is equal to the right-hand side of the equation. My voice squeaked there. Didn't mean to make it squeak, but it did. Number 9. This is the last one we'll do today. Pause the video, give that one a try. All right, hopefully you did well on number 9. Let's switch over and see how you did. What I'm going to do when I approach this problem is I'm going to say, let's split that fraction up over there on the left. So this is going to be 1 over cosecant squared of x times 1 over tangent squared of x. Remember, I'm multiplying here, so when I multiply, just multiply straight across and get 1. Multiply again, I get cosecant squared times tangent squared. Because that's a multiplication symbol there, I can do that. Now, 1 over cosecant squared, that's the same thing as sine squared. And 1 over tangent squared is the same thing as cotangent squared. And then we could say, you know, I know that cotangent squared is the same thing as cosine squared over sine squared. And I'm multiplying this by that sine squared there. Now I want to pause right here and say, I don't immediately always see that. In fact, this is a pre-recorded video, and I go through and I have my notes right here of how to solve each problem, so it looks like I'm just like, boom, this is how you do it. There is some struggle. It's one of the things I miss about being in class, because in class I'll throw a problem on the board, and I'll sit there and struggle in front of you and show you, like, sometimes I got to think about it. And sometimes I go down the wrong path and I say, you know, this is a mess. Let me start over and use one of these other identities or approach the problem in a different way. So it's okay to struggle. It's okay to go down the wrong path. And it's not always straightforward. Boom, this is how you do it. I struggle with it, not struggle with the concepts, but sometimes I struggle with the correct path to take. And then it just takes a little while to get through it. All right. So let's go back and look at this and finish it out. Sine squares cancel. I get cosine squared. Hey, guess what? That is our right-hand side of the equation up there, isn't it? All right. So there are 9 practice problems for you to try out. It doesn't always hurt to go back and try them again if you already went through, you know, wait a few days and try them again, okay? I'm also going to have additional problems for you to try out because I think a bunch of practice problems are what students need to do these successfully, okay? Thanks for watching. Thanks for working hard. Hang in there and have a good day.